Alright, we're going to start lab 2, which is atoms and molecules, and this one is more of a calculations lab, so it's harder for me to show you all the implements that you're going to be using and all the calculations just here, because I don't have a whiteboard. So what you want to do is print off your lab answer, your directions sheet, and then print off your answer sheet, and read thoroughly through your direction sheet, because this is going to be really difficult to understand. Chemistry, for the most part, is one of those ones where you're going to be adding and subtracting electrons, and we want you to get the concept of it. So if you have any questions, please don't hesitate to post on the forum or call me or ask Dr. Mason or go seek help through the Learning Resource Center. So what you need to do, read all the way through it. If you can, read through your chapter that is on chemistry, because you're going to want to know that before you start this lab. Okay, so what I'm going to do is I'm going to take my answer sheet and a periodic table of elements. Now this is a physical copy, but there's one online that I have linked to the actual lab, so that's a good one to use, or you can use any periodic table of elements. So you're going to definitely need this today. Okay, and you will need the pH strips at the end of the lab. So what you're going to start off with is you're going to determine the number of protons, neutrons, and electrons in each of the following atoms. We want you to determine it for helium, magnesium, and silver. Okay, so the number of protons in helium, you have to take your chart and you have to search on your chart where helium is. And helium is number 2 on the elemental chart. So what you will do is the number of protons is always the atomic number on the chart. It's always going to be, helium is always going to be 2. And helium's weight, you will see underneath there, is 4.003. And what you want to do is your number of protons is going to be this atomic number. So protons would be 2. Electrons would also be 2, because we're just dealing with the atom. And to determine the neutrons, you're going to want to take the atomic number and subtract it by the atomic weight. So I would take 2 minus 4.003, and that equals 2.003 in neutrons. So you would end up with 2 protons, 2 neutrons, and 2 electrons. So that's how you do those. Now if you move down to the next area, which it says determine the number of protons, neutrons, and electrons in each of the following ions. Now ions are different from atoms because they have an electrical charge. They can have a positive or a negative electrical charge. And what that means is that an electron has either been lost or gained, and that's why it makes it an ion. And so what you're going to do is determine the number of protons, neutrons, and electrons for the hydrogen ion, which is an H+ ion. And your number of protons, you find your periodic table of elements, and you find hydrogen, and that's number 1. And then you look at the weight underneath it is 1.008. So what you're going to do is the number of protons, just like we discussed before, is going to be the atomic number. So hydrogen, protons would be 1. With neutrons, you want to take the actual atomic number and you want to subtract it by the atomic weight. And that's going to give you, it's 1 minus 1.008, which gives you what's left over is 1.008, which is not enough weight for even a neutron. So you don't have any neutrons in a hydrogen ion. Now to determine the number of electrons, what you're going to do is you're going to look at the ion. Does it have a plus or a minus? This one specifically has a plus on it. So that means it lost an electron. I know it's sort of confusing that when it loses it, there's a plus sign there. So that's really what the confusion is when it comes down to the electrons. So to determine the number of electrons in a hydrogen ion, you would look at the atomic number, because the electrons are always going to be the atomic number, and then you'll determine if it's a plus or a minus behind the ion. And since this is a plus, we know it lost an electron, and since there's only one there, it's 0. So there are no electrons in a hydrogen ion. Okay, so continue to do that for the magnesium ion, and the chlorine ion is a little bit different. I'll tell you how to do that one because it has an electrical charge of a negative charge, and you'll see that behind it. So to determine the number of protons in a chlorine ion, you want to look on the chart and you're going to want to find chlorine. Chlorine is number 17 on the periodic table of elements. Okay? So we know that the protons never change, and it's always going to be the atomic number. So 17 is the atomic number for chlorine, so that's going to be our number of protons. To determine our number of neutrons, we're going to take the atomic number, which is 17, and subtract it by the atomic weight, which is 35.45. You will determine the number of electrons. Now the electrons are always going to be the atomic number, but since this is an ion and it's a chlorine ion that has gained an electron, we're going to take that 17, we'll add 1 to it because it's gained an electron, and that brings us up to 18. So any kind of chlorine ion, you're going to have 17, and then the number of neutrons, and then the number of electrons is going to be 18 because it's a minus charge behind the chlorine ion. Okay, if you're still confused, go to the forum. There's a little post-it on there, and you can see that I've posted Lab Help 2, and it kind of writes it down and does the calculation in the math for you to see in actual text rather than me speaking it to you. Okay, so the next part is part 2, and you want to review the atomic and molecular structures of the specific elements that we've chosen. So carbon, hydrogen, oxygen. Right here we give you the symbol, and we want you to tell us what the element is. We want you to give us this symbol, the protons, the neutrons, the electrons for every single one of them. So fill in this chart the best you can. And you should be able to determine that the number of protons, electrons, and neutrons based on your reading and what you did up here in part 1. Okay, so then you're going to go to part 3. And part 3 is a chart on atoms, ions, and molecules. And this is where we want you to do the protons and electrons of sodium, protons and electrons of chlorine. And then we get a little bit tricky, and we combined atoms. So we want you to find the protons in a sodium chloride molecule. So what you're going to do is take the protons for sodium and take the protons for chlorine, and you're going to add them together, and that will be your answer for that. Same goes for the calcium ion. Since this one has an ion, it has 2 pluses, so you're going to actually subtract 2 electrons from your total number on that. Same with the oxygen, and just continue to fill in the chart based on whether it has plus signs, minus signs, or no signs. Okay? Now the last part is a pH chart, and what we want you to do is take the pH strips and test solutions around your house. Test things that you drink all the time. Test milk, lemon juice, soda. It's kind of good to know what kind of pH you're putting into your body. Anything really acidic might give you a stomach ache. So this is the pH strips that you're going to use. You have about 10 of them in your kit. We're only asking you to test 5 solutions, so you're going to end up with some extras. Or have some fun and test some other things. So you take this and you would put it into some kind of water or solution or anything that you would want to test. And based on the color it turns, you want to match it up with your chart that they give you, and you can determine what pH you have. Just write down what you expect it to be, the acidic, do you expect it to be acidic or basic, and then write down whether it is. So that's all you'll have to do for the last chart, and you would fill in the very bottom chart for that. Okay, and that should conclude Lab 2 for you.